Yum yum!
Hello, Łukasz Pazera here. In this tutorial we're going to build a rig that tests a point against intersecting with a plane. And we're going to detect the cases where the point is above the plane and then its color is red. Then it will test whether it intersects with plane and then its color will be green. And finally, when it's below the plane, its color will be blue. Okay, so let's take a look at how we can approach this problem. So one way to define a plane is by having a point on the plane that we can call P, and then by having a normal vector. So let's draw it like this, and let's call it N. The normal is the vector that is perpendicular to the plane, and this vector also needs to have a length of 1. So if this vector is perpendicular to the plane can go something like this, for example. And obviously the plane is infinite, but I'm just drawing it for simplicity as a square here. So here's our plane, and here's our point on the plane. And now we need point A, which we'll be testing against intersection with a plane. And just as we outlined, we will have 3 cases. So here the point A is above the plane. Then we will have another case where the point A lies on the plane or intersects with the plane. And then finally the third case where the point is below the plane. So let's just color code this. So this is our red case. This is when the point will be green. And here goes the blue one. So how can we test all of our point A cases in relation to the plane? Fortunately, there's a vector operation that is perfect for our case. And this operation is a dot product. So if I have already written it here. So the dot product is an operation on 2 vectors, and if you take the dot product of vector A and vector N, this could be any 2 vectors. I'm just naming them A and N. The result will be scalar x. So basically a single number. It's not going to be another vector. It's going to be just a single number. The dot product is a very common operation in computer graphics, and its result can be interpreted in at least a few ways. In our case, we are interested in taking a dot product of 2 normalized vectors, so we take 2 vectors with the length of 1, and in such case, the result of the dot product will be as follows. When we take a dot product of 2 vectors that are pointing in the same direction, 2 normalized vectors that are pointing in the same direction, the result will be 1. If we take a dot product of 2 vectors that are perpendicular to each other, the result will be 0. And finally, when we take a dot product of 2 vectors that are pointing in exactly opposite directions, the result will be -1. And if we take something in between, so let's say if I do a vector like this, the value here will also be between 0 and 1, so probably in this case something like 0.5. And likewise in the other direction, if we take something like this, vector something like that, then the result might be -0.5. So how does that apply to our problem? Well, it's actually quite simple. If I create a vector PA, so I will have a vector that goes from point P to this case of point A and normalize it. So I set it to the length of 1. You can see that I could take a dot product of those 2 vectors and the result will be greater than 0. If I take this, if I create a PA vector that goes to this case of point A and normalize it, you see that these two, so the N and PA, are now perpendicular. The normalized version of PA are now perpendicular, and the dot product should be 0. And finally, for the last case, now the dot product between the N and the normalized version of PA should be less than 0. And that's pretty much all we need.
Yum yum!